with the simplest one. Point defects. Point defects. Defects that are there at a point only. And the first type we will call vacancy. Right? Vacancy. I always ask you, what is the English language meaning? Vacancy means vacancy, right? Either there is something or it is vacant. So whenever there is empty space, it is vacant. So that is the vacancy. And if you read through here, which we will not read too much, the energy of formation of about 1 electron volt is required to create a vacancy, right? And vacancies are formed because some of the atoms have too much energy, more than 1 electron volt, and they create and they leave the place, and they, or some plastic deformations are there, or rapid cooling is there, or we bombard the material with outside particles, like if we hit by X-rays and so on, right? So by many of these, either by any method, the kinetic energy is increased beyond 1 electron volt. So some of the atoms leave their position and leave vacancies behind, or some plastic deformation has been done, so there is some gaps, or rapid cooling has been there, so there are some air bubbles or gaps, or particle bombardment is being done. By all of this, we get a vacancy. How does it look like? This is a schematic diagram. All these are the atoms. All these are the atoms which are of the material. And because of getting some extra energy, the atom that was here has gone out. So it has left behind a vacancy or an empty space. So now this is a defect. We know that all these particles, if we try to deform them, will resist. But here there is no resistance. So if I apply pressure here, these things will more easily move here. If I apply pressure here, all these atoms are resisting. So there is a resistance to deformation. But wherever there is a vacancy, wherever there is a space, empty space, then there is a defect in the material, right? So this is vacancy. I have again given you the same slide. So after looking at that diagram that we just had, you can read through this, which we have already read. Another type of point defect, try to say it, interstitial C. Interstitial C. Interstitial C. Interstitial C. Interstitial C. So if at any site, interstitial site, there is a point defect, then this point defect is called interstitial C. Interstitial C. Now there are two types. There is a self-interstitial, which is called interstitial C, or there is some other type, right? So self-interstitial is an easier name. So let us see. Now you see, these are the atoms. These are the atoms. And it is a self-interstitial, right? So one of these same atoms, you see, now interstitial would be here and here and here, right? These interstitial gaps, they are small. They are small, right? So if any solute atoms, which is smaller than this size, comes, then an interstitial solid solution will be formed. We are not saying that. We are saying that by any chemical thing, any special energy, these are moving. Now it leaves its place and goes to an interstitial site. So of course it is much bigger than here. It is much bigger. So if this forces itself into an interstitial position, it will push this and push that and push that outside. So you see, at any of these interstitial sites, if a same material, an atom of the same material comes in, then this is an interstitial defect. And what we are showing you here is just that at this location, the lattice constant A will become larger. These are not atoms which have become larger. The atoms are these, and this is also an atom. But this atom has forced itself into an interstitial place, and therefore there is an interstitial gap, and this interstitial defect is there, and a lot of deformation or distortion is there around it. So near this interstitial defect, the size of the lattice constant A will be larger. So this can sometimes happen, and this is the second type of point defect. The first type of point defect was vacancy. The second type of point defect is interstitial defect or interstitial C. Now, there are other type of point defects also in crystal systems. One is called cation anion divacancy, which is also known as Schottky imperfection. Schottky was the scientist who discovered this, right? And we will see how it is a cation anion divacancy. This is describing what type of defect it is, and the name is a Schottky imperfection. On the other hand, there is a vacancy interstitial C pair, a pair of an interstitial defect and a vacancy. And this pair is known as a Frankel imperfection, right? So we will see on the next page when we show you the diagram, there is a Schottky imperfection and there is a Frankel imperfection, right? And these are there. So let us see. Now suppose this is a solid solution, right? What type of solid solution it is? Interstitial. The big ones are the solvent atoms and the small ones are the solute atoms. So the solute atoms are in all the interstitial positions. So this is an interstitial solid solution. But now let us say this has happened. This has happened. You see, one of the larger atoms is vacant, right? One of the larger atoms is vacant. And one of the smaller ones is also vacant, right? So one of the larger ones, the solvent ones, is vacant, and one of the smaller ones, the solute ones, is also vacant. So there is the vacancy created by the solvent, and there is the vacancy created by the solute. So it is a vacancy pair. So a di-vacancy pair. So this whole defect is known as a Schottky imperfection, right? So that is why we described it. One large atom is missing, there is a vacancy. One smaller atom is missing, there is a vacancy. So there is a pair of vacancies, therefore it is a di-vacancy difference. Di-vacancy means two vacancies. And the scientist who discovered it is Mr. Schottky. So this is a Schottky imperfection. Look at the other type. This is the interstitial location. This is the interstitial location, so there is a vacancy. But when this one moves, then rather than going outside, it moves to another interstitial location. There was some extra gap here, right? A little more of gap is there. So it forces inside. So here the solute vacancy is there, right? These are the solute atoms, the small ones. So a solute vacancy is there. And here there is an extra interstitial, right? So this is an interstitial defect. Remember, interstitial defect means there is an, right? So there is an interstitial defect here and there is a vacancy here. So there is a vacancy interstitial C pair, right? That pair was a vacancy pair, and this pair is a vacancy interstitial defect pair. So together this whole defect is known as a Frankel imperfection. Of course, here also the lattice size will change. Here also the lattice size will change. Here also some deformation will be there. Here also some deformation or distortion will be there, right? So until now, how many types of point defect have we studied? A vacancy defect, interstitial or interstitial defect, Schottky imperfection, and Frankel imperfection. So we have studied 4 types of defects which happen at a point. So they are point defects. Okay, good. Now we are talking of line defects. So before starting the line defects, let us take a quick break. And sometimes we give you a mental break. So today, let me give you that, right? I don't know if I have told you this before, but maybe if it is a repeat, then I'm sorry about it. This is a mathematical statistical joke. You guys study a course on probability statistics. Some of you may have done it, some of you will do it later on. So there are 2 statistics professors who are flying in an aeroplane. I don't know if I have told you before. If I have, again, as I said, I'm sorry. And after some time, the captain comes on the mic and says that we are very sorry. We have to tell you that there is a problem. This is a four-engine plane. This is a four-engine plane, and one of the engines has stopped working. But don't worry, the plane is very strong. With even three engines, it will keep on traveling, no problem. The only thing will be that because one engine has stopped, therefore we will take a little longer, maybe 2.5 hours longer. So we will give you an extra snack, some biscuits and some coffee, and please enjoy. After some hours, the pilot announces again that we have another announcement which is bad. One more engine has failed, but again, do not worry. This plane is very strong, and even with only two engines, it will run, inshallah. But there will be a longer break. We may be late by about 4 hours now. I'm very sorry, maybe 5 hours. But fortunately, we had packed some extra meals, so we will serve you an extra lunch. So please enjoy that extra lunch, and I am sorry, and so on. After some time, the captain comes again that we are really sorry. Third engine has also failed, but the plane is very strong. It can still run on a single engine. But of course, now we will be very late. We'll be late by 6, 7, 8 hours now. And I am very sorry. We will try to give you whatever extra snacks and coffee and so on. And we will be now too late, but we will try to reach, inshallah. And just for you to pass the time, we will show you some extra movies and so forth. Now these two professors are sitting side by side. They are both professors of statistics. They were going to travel to a conference where they will be presenting some papers. So you see, one engine failed, late by 2-3 hours. Two engine failed, late by 3-4 hours. Three engine failed, late by 9-10 hours. So now this one statistics professor says to the other, thank God all the four engines have not failed. Otherwise we would be late by at least 15 hours. Joke is finished. We will see you after the gap, inshallah.